A very good morning to everyone. It gives me immense pleasure to welcome you all to this session on creating futuristic buildings with IoT, hosted by EDUREKA and sponsored by Intel. EDUREKA is an e-learning platform leading the innovation of learning since 2012. So far, we have conducted more than 1,500 sessions and have helped over millions of professionals and students across various industries. Today, we are pleased to have Mr. Aviru Basu on board, who has been an Intel software innovator since 2015 and has won the Top Innovator Award for 3 consecutive years. Through this session, he will be addressing to the doubts on smart buildings using IoT. So without any further ado, let's get started. So Mr. Aviru Basu, please take over the session.
Sure. Just a second. Hi, good morning, everyone. Welcome to the session. It's a Sunday morning. I guess you already have lots of energy. So I'm gonna begin very soon. Cool. Awesome. So before we go into the session, let me just brief you all about like what we're going to discuss today. Today's discussion will be all about IoT and how it can be applied to the concept of smart buildings. This won't be a session like where you understand the deep technical walkthrough, because obviously that's going to take a lot of time and not possible for one day session. But what I will try to cover is try to give you some concepts about how IoT is helping to drive the innovation in the real estate business, and also how these new things or stuffs can be applied for making buildings more secured, more accessible, more safe, and so on. So we are going to discuss about sensors, we are going to discuss about communication protocols, we are going to discuss about AI on edge, and finally introduce to you some of the Intel parts to it, as in how this all can be achieved in a single under a single umbrella, and move on with that. So even before starting with like smart buildings, let us understand what exactly is IoT, or what is the concept behind it. So IoT is all about smart devices, and now by smart we don't mean that we are not referring to like a smart AI system, like a smart digital assistant. Obviously, that is a part of it, but by smart, what we commonly refer to as connected. So anything that is connected to the internet, that shares data with the internet. By data, I mean like sends or receives events, collects data, sends it, receives data, executes an action. Those stuffs we refer to as smart. And every day in today's world, every day new devices are being launched, which they typically call it a smart device. For instance, you have a normal bulb, you have a smart bulb. You have a normal, before we had normal cell phones, now we have smartphones. Before you have like normal fans, now you have smart fans. Normal lighting, smart lighting. So if you just go like do a deep dive and just go visit an e-commerce website and search for smart bulbs, smartphones, and smart whatever, just append the word smart in front of it, then by default it means that it is connected to the internet, or it shares data. So connecting to the internet means like it won't do nothing. It will obviously share some data. For instance, take a car. Like I have a Tata Nexon with me, and it's a smart car. How? Because it shares the data with me over the internet. That's how simple it is. So nowadays, everything that is being launched in today's world is basically smart, and it shares data. It is connected to the internet, and that's all about the future of IoT is launching smart devices. But before that, let's do a bit of technical walkthrough, as in what exactly is IoT. Um, IoT is all about things, or rather connected things. So you have, by things are referring to devices. Say it might be your cell phone, it might be your electric bulb, it might be your switch box, it might be your gate. It can be any physical hardware object. Now there's a component of network to it. So this network is basically either it's an intranet or internet or somehow which connects all these things. And all these things are connected to this network. Now this network can be either locally hosted or globally hosted. So IoT is nothing but just a combination of multiple things connected to a network. So that's what I've mentioned, like connecting things to network. So that's what IoT is all about. And a system, if we try to define what exactly is IoT, I mean, there's no such definition as such. But if I try to bring it up, then it is like it's a system of computing devices which have a unique ID capable of transmitting data over the network. Yeah, cool. So as I said earlier, like we have this smart devices concept, there's smart things concept, smart bulbs, smart buildings, all these things. So essentially these are like devices which are connected to a network, receiving, transmitting data. They have an unique identifier by which are able to identify. And that's probably the most simplest form of definition of IoT that is possible. So if I look at the components, these are a bit of technical slides in which I'm just going to refer to basics of IoT, and then we are going to move forward with the advanced part of it. So typically a thing consists of three components, which is the MCU, the sensor, and the actuator. So MCU is something we call as a microcontroller unit, which can be your Raspberry Pi, an Arduino, or anything as such. Then you have the sensors and the actuators. The sensors are the physical devices which converts the physical world and try to extract digital information out of it. So you can say that a temperature sensor senses the temperature of the outside world and returns us the value of the temperature in form of some digital uh, bits. So sensors essentially converts the physical world into a digital replica of it. And then you have actuators. Actuators are nothing but it is simply the electromechanical component. So anything that we have to interact with the physical world, for example, motors, fans, servos, all these things are actuators. So what happens is the sensors send the data to our MCU or the microcontroller unit, and the MCU sends the data to the actuators to take an action. And then we have a network layer. Network layer might be either local or global. So local network is basically, it might be locally hosted, not connected to the internet, and or it might be globally hosted, in which it might be hosted to any cloud service like Azure cloud or AWS cloud or anything as such. Now typically a network layer will consist of a messaging server and a data operations part of it. So messaging server, I mean, we pretty much know the network OSI layer, the network model and all those things. But here I'm not going to discuss about those things because those are commonly found over the internet. So this is my perspective of what the network component of IoT should consist. It ideally consists of a messaging server and a data operations part of it. So messaging server is nothing but how these things, this combination of MCU sensors and actuators um, interact with each other or interact with the cloud. So messaging server is basically a central hub through where all the messages gets transferred, either between things or from things to network or mobile application to things or vice versa or anything. So a messaging server typically might be a MQTT broker. I hope you know what is MQTT. If you don't, like, you can just Google search about it. MQTT stands for Message Queue Telemetry Transport. It's based on a publisher subscriber architecture. So we have a messaging server, we have a data operations block to it. And finally, we have an application which controls or monitors this entire thing. Now, the data operations part of it means what to do with this huge chunks of data that we are collecting. So this can be your sensor data, this can be your, this can be anything starting from computer vision data, it can be a sensor data, it can be some user information data, it can be anything. So what to do with this data? That's very important. And that is something that's been taken care of by data operations. So this internally can consist of rule engines, some visualization tool, and so on. So again, to recap, we have a things layer, which is pretty much nothing but just a base silicon component of it, which consists of sensors, MCU, and actuators. And then you have the network layer, which consists of messaging server and the data operations part of it. And finally, an application for doing all the subs, doing all the magic. Now let's see what exactly is smart building. Well, the concept of smart building with IoT, I mentioned a slide as well, and it's just my own words. It's nothing new. Just think about it. You visit a bank, or you let's say you visit an ATM. I think ATM has been existing for many years now. I remember when initially I used to go to an ATM, I used to insert my card at the door, and then the ATM door would have been opened. Right now, you can just push the door and you can get inside. But before you insert a card to the ATM door, and then the gate will open, then only we can enter. And while returning, we have to press a switch to unlock the door. So that has been my first exposure to the concept of smart building. Because to enter the building, you need to insert ATM card. Now think about your office. To enter your office, you need to scan your ID card. The ID card consists of some kind of an RFID component, which you scan to the RFID reader, and then the door unlocks. So that's kind of a smart building, to be honest. The smart building definition might vary, and it's not just limited to security. It's making the entire ecosystem of building a lot smarter, a lot interactive, a lot secured, and a lot comfortable. So what I mean to say is that consider any system in a building. Now, a building can consist of many systems: the electrical system, the heating system, the HVAC or the ventilation part of it, the security aspect of it, uh, the safety part of it, many systems it can consider. It's basically a very magnified version of a city, to be honest. And if you are able to monitor and control all these buildings, on all these subsystems of a buildings, then you need to bring up the component of IoT into it. So let's take consideration of any particular subsystem. Let's take into consideration of a, let's say, home automation system or a small lighting system. Now, if you want to control your lights, or you want to control your AC, or you want to control your fan from this chair without even getting up, then then you need to connect those things to the internet, or you need to connect those things to a network through which you'll be able to interact with it. So basically connecting all these things, or all these sub components or subsystems to the internet, to the network, will allow us to interact with the subsystems from the comfort of our own room and monitor it, take intelligent decisions. Machine learning algorithms can run at the back end, which will allow us to like trigger some predictive maintenance alerts and all those things. So that's how the smartness comes into buildings. And obviously, the last pointer being safety is ensured by tons of sensors. So you might have monoxide sensors, carbon monoxide sensors, motion sensor, fire, smoke, and the thousands of more sensors that can be integrated in the building. You can even integrate a vibration sensor, stress and strain sensors to see how the building is holding up for all the load. Even during an earthquake, uh, when the building shakes very violently because of the earthquake, and the place where I stay, we receive a lot of earthquakes. So we pretty much understand, like, the buildings goes through a lot of stress and strain, and it gets very important for us to determine whether the building is safe to use uh, when I mean after the earthquake has happened, or after, if the building has survived, if we can stay inside the building. So to monitor all those parameters, we can use a lot of sensors, and we solely don't need to depend upon the human verification part of it. You can have a computer algorithm running in the backend, which will take the decisions for you. So that's how we can make the buildings a lot safer, a lot smarter. The sensors are everything in buildings. That is kind of true. Why so? Because whatever I've discussed over here in consider smart building, every physical parameter that we want to interact to a building um, has to be done with sensors. It cannot interact directly with any physical component. That is not physically possible. So how it can help us, it can improve the building energy efficiency and sustainability. How? Let's take a very quick example. You have, everybody has a switchboard in their house, right? And sometimes it happens with me a lot. I keep one of the light switch on. I probably go downstairs to have some snacks, and I forget that my switch was on. And by the time it's the end of the month, I probably have added probably some hundreds of rupees to my electricity bill. And the example will be like, if my AC is running, I step out from my house, let's say for even for 2 to 3 minutes, I forget to switch off the AC, and the AC keeps on running. And at the end of the month, I get a huge electric bill. And the example will be, if your house is running on an old wiring system, like what happened in my case, the electricity bill is to be considerably high. And it was getting very difficult for us to determine, like, where is this power being used? Like, even if only one light and on one fan was on, or only one PC was running, it would have been very difficult to, at the end of the month, to estimate why this amount of bill is coming. So there was no proper monitoring in place. So what we did was that we inserted lots of current and voltage sensors across different electrical appliances. And we started monitoring the amount of power utilized by these devices. At the end, we found out there was a huge gap between the power utilized by these devices at the end of the month and the amount of power as being shown in the electricity bill. There was a huge gap. And then we realized that it was all the fault of the old wiring system. Once we upgraded to the new wiring system, the electricity bill dropped exponentially. And that's the magic of it, because before we were not able to figure out what is wrong, what is happening. After we install sensors, and this magic happened. And this is not just the case of my house. I mean, not everybody would like to experiment with electrical systems, something like this. There's a specific use case in Kolkata, in West Bengal, where an entire IT building, like a co-working space, was like monitored for energy consumption. And at the end of the 3 month quarter period, they were able to save 67 lakhs of rupees in terms of electricity bill alone. So we are able to increase the energy efficiency and sustainability of a building just by monitoring the amount of energy consumed by these devices. And how you're monitoring those? Using sensors. So that's a very important concept of smart building, in which we can reduce the cost, increase the efficiency of a particular building, and again reduce maintenance costs and with predictive maintenance. And this is something which I taught before in terms of the earthquake scenario, or in terms of like where we stay, we also receive a lot of rainfall. And recently we have installed something known as a truss. Like at the top of the terrace, we have installed tin sheds to cut the speed of the rainfall and protect the upper flooring of it. How we could determine? Because the moisture sensors that are available at I mean, we can monitor the moisture content at the underside of the ceiling. Like this is my ceiling above the rainfalls, and here we can determine the moisture content. So rainy season, the moisture content was getting particularly very high on the underside of the ceiling, and that was damaging the ceiling a lot. Now, when we installed truss, when we did a bit of chemical treatment, we were able to reduce those moisture content a lot, and thus saving the ceiling as a whole. So this kind of things comes a lot handy. Now, here is another thing which I mentioned is a very small scale scenario. Now, if you consider a big, huge complex, like probably tens of buildings in a single complex. In those scenarios, monitoring, maintenance is a very important factor. By maintenance, we can refer to the water system, to the electrical system. We don't know what might go wrong at any time. So we need to monitor all these things, and then intelligent algorithms will need to take up the decision as in what might go wrong or what can go wrong, and then suggest the owner of the building, like, you must have a look into the subsystem and change it. So that is also very important. Optimized space utilization is something which is very useful in the case of parking. So if your parking sensors enabled in your parking lot, then it will be very easy for a particular driver to come over there and park the vehicle. Otherwise, you might park anywhere you feel like, without considering that there might be some empty spaces. Um, like, let's say we have two stack of rows of cars. Now, if you just park your car in the front row, then the back row, even if it's empty, cannot be utilized. So the space utilization becomes very important. And another aspect of space utilization is in the concept of interior designing, which I don't want to discuss right now, take a lot of time. So, but moreover, you can say that space utilization is a very important factor when it comes to smart buildings. And the last point being enhanced tenant security, comfort, and safety. This, I think, is pretty much evident how we have motion sensors, uh, we have fire sensors, smoke sensors. Then all this can detect the presence of any like fire or any burning substances. Then this motion sensor can be used for detecting intruders or intrusions. And finally, at the very ground level, you can have CCTV cameras, which are hooked up to an AI edge system, which I'll discuss later of this presentation. And that will help the tenants to identify who is coming to the house, interact with the guest even before opening the door. And this kind of system exists till date, and we are using it on a regular basis. So this increases a lot of security, comfort, and safety for the tenants as well. Here is a scenario in which we are actually like, what I have done is nothing, simply put up this couple of pointers in context of automation, like basic home automation. Because when I entered in the world of IoT, and probably everybody is aware of the fact that the hello world of IoT is nothing but just home automation. So that home automation itself is a part of the futuristic building concept. So why not try it? So I also did the same thing. And I would advise you, like, if you want to get into IoT, into the futuristic building concept, then also start with home automation. So what exactly is basic automation? Here I've just given you the example of lights and HVAC systems. So home automation in terms of light and HVAC control. So HVAC, I mean AC or heater, that is a ventilation subsystem. Then light subsystem, all this can be controlled. How? I will tell you. Switch on and off, setting of color and brightness level of lights. I think everybody is pretty much aware of this thing. Um Philips Hue lights, smart lights. Nowadays, the smart lights are available within 500 rupees. We have companies like Wipro coming up, Infosys coming. So they're all coming up with their own smart lights. And what it does is, like, these are like RGB lights. It gives a 60 million combination of colors. You can set whatever color you want. In fact, if I just pitch up the camera a bit, the light that you can see here is nothing but just a smart light. So I can still control those light. Just a second. I can still control this light using a mobile app, and that's how it is. So, like basic automation of lights, basic automation of ACs, um, all these are part of the smart building ecosystem. Temperature control of HVAC systems. So if you're able to remotely control your AC, so let's say if you're entering your house in a hot summer afternoon after a long day of work, or probably visiting some banks where you have to stand in a huge queue and you're sweating like anything, and you want to just come to your house, take a shower, and just rest. And at that time, you will definitely not want to come back to your house and wait for the AC to cool down your room. For me, what happens is that the room that I stay has a tin shading, and it gets excessively hot like a microwave oven during the summertime. And I would definitely want my AC to be on at least 5 to 10 minutes before I enter my house or enter my room. So that's how it happens. And what I've done is like simply automated my AC. I've connected a system to it, and I can control my AC using a cell phone now. And whenever like such a scenario pops up, I will simply set the AC to a particular temperature when I'm outside, and then when I just enter, I will see the room is already cooled down for me. So I know it's making our lives a lot lazy, but at the same time, it is increasing comfort, it is increasing security and safety. So why not use it? And automation of doors, windows, and blinds. So this is also, it's pretty much evident, like you can control your Roman blinds for your windows, then the doors like unlock and lock the door, which again is implemented in one of my kits. Like whatever I've written here, I at some point or the other, either I have tried implementing it in my house, or probably I have implemented it and it's currently in working stage. So like all of these are achievable, and these are not like rocket science or anything. These are achievable, and this can be done just by investing a couple of rupees into it. It's not like you need to spend lakhs and lakhs of rupees. It's not like something like that. You can do it in a couple of like hundreds of rupees, or probably within 5,000 you can automate your own house. And that's the beauty of it. So I was able to automate my door. I was able to lock it, unlock it, all by using a mobile app. Blinds I was not able to do because I don't have that kind of blinds available to me. But yes, doors and locks, all this can be automated. And how it can be done, or what all the possibilities, we'll discuss very soon in the upcoming sections. So it's, as I said earlier, it's all about making our lives easier with all the stuffs at our fingertips. How it, like controlling our lights by just using a cell phone, controlling your AC using a cell phone, monitoring your CCTV camera using a cell phone. And that also, you don't have to be inside a premise. You can stay anywhere in the world and can monitor your house. I mean, it's not that much essential to do it, but yeah, from a security standpoint, it is very essential. So it is just making our lives a lot easier, a lot, to be honest, lazier, and increase the security part of it by bringing in every controllable component at our fingertips. And nowadays, we're even shifting from the concept of mobile apps. We're shifting everything to a voice-based system, to Alexa, to Google Home, to Siri, and all those things. So it's all about like this is a change that is happening now. So you consider building, you consider how you can make the building a lot smarter, and how you can get all the data from it, how you can control each and every parameters, and all can be done by just a single place. It's not that you have to go and switch on and off and everything of that sort. And it makes the life a lot easier, and that's how it is. So pretty much up till now, we have given you a very basic introduction about the concept of smart buildings and the concept of IoT. And now we are going to see like how these things can be applied to our houses to increase safety, to, I mean, a bit of more technical deep dive. For that, let's see like how to increase the safety in our houses. This is something, yeah, just a second. Yeah. So how do you increase safety in our houses? So by safety, we are referring to like multiple pointers, which includes tenant safety, which includes the safety of buildings, which includes safety of your all systems, safety of the electrical system, safety of your fire system, safety of our AC, safety of each and everything, every component, basically monitoring each and every component. So how we can increase the safety of our houses? The first point that comes to mind, and this system has been existing since a long period of time, real long period of time, which is a facial recognition based safety system. Uh, how this thing works is that, let's say, uh, you have a room. I mean, you are living in a house that's shared by many people, like you, your mom, your dad, your wife, your kids, and uh, so on. So you like you have this facial recognition system implemented in a house. So whenever somebody of a family enters your house, you don't have to like go and open the door. The door can be automatically opened. And it's not about that. You can even add your family members, so you don't have to ask like who is there and who is coming. I mean, it will just do the job for you. Now, motion detection sensors for intrusion alerts. This is something which is implemented in the concept of intrusion alerts as well. But I have seen this being implemented in lots of offices and even in my washroom in the concept of switching off the lights in case of washroom. So if you're not using the washroom, if no motion is detected within the washroom, then the light will go off. While if a motion is detected when you enter a washroom, if the motion is detected, there's a sensor called a PIR sensor or passive infrared sensor. So whenever you enter the washroom, it detects a motion and it triggers the light to be switched on. So motion detectors can be used both for automation in an area which is not quite used often, and also for intrusion alerts. So let's say it is there in your hallway and you're not expecting anyone in the hallway after, let's say, 10 p.m. or 11 p.m. in the night. So you can switch on this motion detection system after 11 p.m. And if anyone comes in the hallway, then you will have a kind of an alarm or kind of a notification sent to your cell phone, along with a picture captured, like who was there and so on. So this is the area where motion sensors or motion detection sensors are, or all these things can be put to good use. Now there are sound sensors available for glass break as well. And this I've seen to some of my friends' house back in the USA, where they have installed this dome-like microphone kind of a system just beside the glass wall. I mean, beside the glass window in the wall. So if by chance, if there's a probability that the glass broke off, then that particular sound is captured and that triggers an alarm. So this is kind of a very interesting concept that I've seen people using in the foreign countries. I have not seen much of implementation in India as of now, but I like, and this is a very nice concept that can be applied. The possible reason it might be applied to offices, it might be applied to banks, it might be applied to all these areas where glass windows are being used, and even to your homes. Obviously, it is not required in case of high-rise buildings because that is not possible. Uh, I mean, for someone to enter. But yeah, these sound sensors are used for glass break detection, and many things. And yeah, how to increase safety in a house is, as a title slide says, there are many more areas where this can be used. It can be used in pretty much detection of fires, smoke, carbon monoxide poisoning. Many places can be used. Even let's say if you have an infant in your house and you're monitoring the room 24/7 using cameras, using sensors and so on. So if it like deviates from the standard parameters that have set, the levels of carbon dioxide, carbon monoxide, and all those things, then you can trigger an alarm to your cell phone or some kind of notification, which will make your lives a lot easier. Cool. So so these are the some ways in how you can increase the safety in your houses. We are gonna discuss about the computer vision part of it at the end of this presentation, where this facial recognition system can be hooked up to the Intel component of Opencv and how you can explore it. So yeah, and this is a particular slide that I mean, if I go to the internet and search for smart homes, there are many things that I'll get. But this is something which I just came up with my mind alone, and like probably the most crude form of smart homes ecosystem that you can see. So what I've done is divided into three subsection: ease of use, monitoring and safety, and security and access control. So under ease of use, we have the simple scenarios of home automation, which includes lights, fans, HVAC system, sprinklers, doors, blinds, windows, and possibly many more if I've missed something. Sprinklers, or you can even say drip irrigation kits. This is a subsection of agricultural component in which, I mean, if you have a like tendency of like terrace gardening or house gardening, and you might not want to water the plants physically every day, then you might set up a drip irrigation system, which is kind of very cheaply available in India. In Amazon, you can get it for like $200. And if you just spread all those drip irrigation system over your plants, and then you can simply trigger the irrigation system by the press of a button or by using a mobile app. This is something which again has implemented in my terrace garden. So that's why I'm kind of interested towards it. This is the ease of use section, in which makes the life a lot easier in terms of control and automation. Then you have the monitoring and safety part of it, which is basically like monitoring different parameters like carbon monoxide, fire, smoke, electrical systems, stress on pillars. This is a very important concept of the structural health of the house. Now, these are quite used in skyscrapers to analyze the health of the particular building. And then you have vibration, which can be used for detection of the earthquakes, then whether building is overloaded or something of this sort. And finally, the water quality monitoring. Now, all these points I've tried to mention the upcoming slides as far as possible, but to some extent, at a very high level, you can consider monitoring safety to be of all these parameters. And finally, you have the security and access control, which includes your tenant safety, which includes the human intrusion part of it that I discussed earlier, then a visitor and guest access control and motion-based monitoring. So all this comes in the security part of it. And the monitoring part consists of monitoring multiple parameters, and the ease of use, like it's just automating things, making the lives lazier, to be honest. And combining all these three systems into smart home, into a single home, converts, adds the word smart in front of it, and gets converted to smart homes. The smart homes is basically a combination of these three subsystems at a very high level. But now here is a point, and here is a $1 million question. How, with so many technologies, with so many stuff, with so many sensors, how do you combine it? I mean, we have sensors, we have motion sensors, we have cameras, we have whatnot. How do we combine it? I mean, no idea, no freaking idea. We have the sensors, we're getting the data in an Arduino or a Raspberry Pi. Now this light I'm able to control using a mobile app. I have another company smart light at my home, which I have to go to another app and control it. With so many stuffs, with so many, how do we combine it? How do you control it? How do you monitor it? It's $1 million question. And that's where the concept of IoT and a bit technical aspect of IoT comes in a picture. And it's where we understand, or we try to figure out the part of IoT where we actually architect the system, where we actually design the system. The design aspect of IoT comes into the picture. So here I will consider two different architectural systems or different architectural point of view of IoT. And like it at a very high level, it can be considered two decentralized system and centralized subsystem. So at a very base level, you have things. Now things can be anything. It can be your like smart bus. It can be your CCTV cameras. It can be anything which has some form of connectivity. Obviously, even it can be a smartphone. Your smartphone is the smartphone, according to me, is the first ever IoT device. Then you have some kind of a network connectivity, and then you have the IoT platform or cloud. And finally, all these things are connected to each other. So things are connected to network. Network is connected to the cloud. Network connectivity provides connectivity to the cloud, and that's how all the things function. This is a decentralized system. What I mean is, like, your things are directly connected to the internet without any medium. Now, it might be a Wi-Fi router, or it might be your mobile BTS tower, which is located somewhere in a locality, but these have direct connectivity to the internet. For example, if you're using a cell phone, your cell phone has direct connectivity to the internet, and there is no in-between medium to it. So that's a decentralized concept. Now comes the concept of centralized system, where again you have things. You have the IoT platform or cloud, you have the network connectivity, and here is the main part to it. That is a local IoT gateway. Now, here is an important concept that I will just take some time to discuss with you. Leave the concept of smart buildings aside, park it aside for now, just for the time being. Think of a scenario in which you have a vast agricultural field, hectares and hectares of agricultural field, or even leave the agricultural field. Okay, let's consider it. And you have like hundreds of sensors embedded within the agricultural field. Now, what the sensors do, probably monitor your temperature, monitor humidity, monitor your like plant moisture, and tons of other parameters. Now, at a very practical level, will it be possible for me, for a single person, to go and change the batteries, or to rather to change the connectivity for all of the sensors every single day? Like, think of a cell phone. Your cell phone also collects data. Now, how much your cell phone runs in a single charge? 2 days at the most, 3 days, probably, with the huge battery stacks we get, at the most, not more than that. Now, is it possible for a single human being to go and do like reset batteries, reset all these things every 3 days? It's not possible. That's why, instead of providing direct connectivity to the internet, which consumes a lot of power, it is done via some kind of a gateway. Now, these things are connected to gateway via some RF protocol, which I will discuss very soon. And this gateway provides connectivity to the internet, as in how it is showcased here. So why we are introducing a concept of gateway in between? Because of two simple reasons: to save power, and some of these devices don't have the capability out of the box to connect to the internet directly. You cannot connect to the internet without having a SIM card access, without having a Wi-Fi RF into it. So that's not possible. And when you are bringing in Wi-Fi component, or you're bringing in cellular component like 4G or 5G, it consumes a lot of battery. So that's not possible, and that's very difficult. And that's why the concept of gateway. Things are connected to gateway, IoT gateway, and the IoT gateway connected to a network connectivity. Now, this IoT gateway might sit somewhere in an agricultural field connected to power, which you can simply access whenever you want. And this gateway will provide you the gateway, as the name suggests, to the internet. So this is a concept centralized system. So before, we had the decentralized system in which things are directly connected to the internet. And now you have the concept of centralized system, in which your connectivity is provided to the internet through some medium or through some gateway. These are the most important architectures that we use in IoT. Technically speaking, if I just think at a very, very, very high level, or very low level to be exact, technically all the systems that we speak about today is a centralized system. You can ask me how. Think of this scenario. Your cell phones are connected to the internet via mobile BTS tower. In this case, a mobile BTS tower acts as a gateway. Your cell phone is connected to the internet via Wi-Fi router. Now your Wi-Fi router acts as a gateway. But why in IoT we specify the term IoT gateway, local IoT gateway? Because it supports tons of other protocols as well. Not only Wi-Fi and cellular, but also other protocols. And that's why IoT gateway is kind of different, but at a very high level or a low level, I might get confused out here. And you guys might also get confused. But at that kind of level, everything is a decentralized system in case of IoT or network. Now, this is pretty much self-explanatory. I will tell you why I've included this slide. Like, there are only two ways in which I can communicate to the internet. Honestly, only two ways: Wi-Fi and cellular. Now, how we are communicating with a device which has Wi-Fi connectivity to the internet is a different story altogether. And cellular, it might include 2G, 3G, 4G, 5G, LTE-M, NB-IoT, and lots of other things. And yeah, so a couple of RF-based protocols that I wanted to discuss. So what are these RF-based protocols? I will just go back to this particular slide. Things are connected to gateway to local connectivity, and network connectivity, and network connectivity provides to the cloud. So this first block, that is from things to local IoT gateway. This particular block here, we sometimes use something known as a RF protocol for communication. So which includes some of these technologies: LoRa, which stands for like long range. Then you have Sigfox, Zigbee, pretty much is very widely used, and BLE, again, widely used protocol. we call it as a Bluetooth low energy. So I'm not gonna go into the details of it, but at a very high level, what I can say is that LoRa, Sigfox, Zigbee, BLE, all these are RF-based protocols which are designed for IoT systems. So this consumes a lot less power. And what happens is that um, you will be having you'll be having these things which are connected to the IoT gateway using these RF-based protocols, and the gateway will then convert these protocols, like will receive these packets through these protocols and forward it after some basic processing or not to the internet. That's how the entire architecture is designed in case of IoT. Now there are cellular IoT protocols. The standard cellular communication we all know, 2G, 3G, 4G, 5G, is pretty much evident. And then there are IoT standard for cellular communication. The above one, this orange color block, that's 2G, 3G, 4G, 5G, these are not meant for IoT use. However, in India, 2G is used a lot, even nowadays, for M2M communication, machine to machine communication. Now, the problem with these protocols is that since they are not meant for IoT use, so they are specifically not very efficient. They consume a lot more power and a lot more bandwidth. However, when it comes to the IoT standard cellular uh, protocols, then you have something known as a Cat1M or LTEM, which stands for LTE for mobility, like for mobile devices, and narrowband IoT or NB-IoT. These two are new standards of cellular communication specifically designed for IoT. Now, here is the bad news. As of now in India, we do not have LTM and NB-IoT connectivity for commercial use. And that's the worst part. I hope these telecommunication giants like Jio and Airtel comes up with something very soon. But recently in the news, what I've heard is that BSNL are teaming up with some space tech company to provide NB-IoT connectivity for IoT using satellite communication. So if that happens, it's going to be a game changer. Then we'll be able to finally shift from 2G to the newest technology. But as of now, as of this date, according to my knowledge, we don't have anything related to Cat1M or LTM or NB-IoT in India. We do have outside India. We even have in Sri Lanka and China and USA as well. But as of now, we don't have these things. I mean, lots of companies are trying for it, but as of now, we don't have, unfortunately. And these protocols are, since are purely designed for IoT, so this consumes a lot less power and a lot less bandwidth. That's the interesting part. Now, finally, we are going to understand like what is the role of computer vision in case of IoT. So this is specifically used for facial recognition security system, as in detection of a license plate or registration number of your vehicle. It might be used to estimate like who is coming in terms of facial recognition. Can be used for automation of automated gates and parking systems, as in to open the gate automatically if a registered tenant is entering the building. You can like scan the registration number plate, and if it exists in a list, then you can simply open the gate by itself. Detection and recognition of objects at multiple levels. So this might include like garbage detection, foreign object detection on the road, presence of foreign objects in a swimming pool. Uh, it can be done, like computer vision can be used to do a lot of stuff when it comes to IoT, especially when it comes to building security and a lot more things. I think another hello world example for IoT, not for IoT, for machine learning or AI, is probably object recognition. That's a hello world for machine learning. The hello world for IoT is home automation. And if you combine these two, you get a smart system. So computer vision for IoT is specifically, we can say it is restricted to recognition of objects, recognition of building. Probably we can even detect cracks. We can analyze infrared images to see the stress level of a building. Maintenance can be done using computer vision. And at a later part of this presentation, after the break, we are gonna discussing about this aspect and how Opencv can be applied to this computer vision systems in IoT, and what is this concept of AI on edge. Those part we'll be discussing at a later point today. So for now, just understand like computer vision is all about recognizing stuffs and detecting stuffs using the camera. So I think it's a time for us to take a break for a couple of minutes, and then we'll be resuming back with the consider smart buildings using IoT. So at this point, I'm gonna open the session for question answers up till now. So please throw your questions in the Q&A chat or in the chat window. Just give me a minute and I will be back with the second part of this presentation. Okay, so I'm gonna take up the questions now. Cool. So first question is from Arpan. Uh, I am not aware what you're trying. Arpan, if you could just elaborate and say what you're trying to mean, like it should be capacity. I'm not able to get that question. Okay. The second question from Arpan is for a smart building and a protected area, there must be a systematic connection plan. Yeah, that is correct, Urban. And like we'll be discussing this again in the later part of today's presentation. The plan is that your devices should communicate to the internet ultimately. Now, how we are able to control or monitor those devices over the internet is dependent upon like how you design the systems. Ideally, we use gateways because it is not possible for us to, like, let's say if it is connected to the internet, then it will consume a lot more bandwidth, a lot more power. And sometimes it is not possible for us to reach all those areas where the sensors installed. So what we do is like we install a medium in the in between a gateway, and we collect all the data in the gateway, and we are in a position to configure the gateway to monitor the gateway for all the incoming events, and then we can forward this package to the cloud. So when you talk about systematic connection plan, it is how you design the system. If your system involves only one sensor, then you don't need to invest on a gateway. If it even includes like up to 5 or 10 sensors, then also it's okay not to use a gateway. However, if your system consists of more than 50 sensors or like hundreds of sensors, then obviously you need to go for a gateway kind of a architecture. Otherwise, you can directly connect to the internet either via Wi-Fi or via cellular communication. The same question is by Adarsh. I want to do some IoT project based on software, not hardware. Well, that's very interesting. And many people ask this question. And to answer you out here is that there are many scope of IoT, huge scope of IoT in terms of software. Technically speaking, most of it is in software, as in now, like pretty much many countries have a monopoly on the hardware section. As you already know, like either it's China or it's Taiwan or it's South Korea, they have a monopoly on the manufacturing side of it. So if you want to get into the software part of it, then it has to be, you can exploit in multiple levels. It might be on the IoT platform. or the cloud computational layer, where you are actually designing the system, playing with the data, and designing the visualization part of it, the software part of it, how you're able to control the systems, how you're able to monitor the systems. All these things comes into the concept of software. Technically speaking, according to my experience in the world of IoT, 10% is hardware, 90% is software. And every people get this wrong, where they consider 10% as software, 90% is hardware, but it's not the case. It's 10% that is hardware, and the rest 90% is software. I work for a company which is in USA called P360, and I'm the IoT lead of that company. And pretty much I've designed the system in such a way such that we can do any kind of modifications to the hardware just based on the software. So we have an entire dedicated team for the software section, while for this hardware section, we are having like 2 or 3 people. However, the team is quite large in terms of software. So you can try to get an estimate, like in the world of IoT, the majority part is software, while the minority part is hardware. And hardware, there are lots of companies that are working on it. However, software part of it, like people tend to get confused. So yeah, you have a lot of scope. So the next question is by Kushma. Please suggest some kind of problems where we still need some research to be done. Well, there are lots of fields. The first one and the foremost being the IoT security. IoT security is still unexplored, lot of unexplored, and there are many areas in which you can tackle the security aspect of IoT in terms of like hardware security, in terms of network security, in terms of software security. Security is a very crucial research area in terms of IoT. Then you have the entire domain open up for you for computer vision or machine learning research part of IoT, in which you are analyzing the data science, the machine learning part of it. Then there's another very important concept. If you are a hardware person, then you can design all those hardware stuffs. I mean, like how you can design a new hardware system uh, with that consumes a lot less power, which has a more efficient power usage, more efficient battery life. There are tons of research that you can do on IoT. I do not know whether a software person or hardware person, but there are tons of scope in both the fields combined. Okay. Can you tell us some of the IoT applications in our daily life? For me and for everyone out there, the first application of IoT in daily life is a cell phone. It's just a cell phone, because you use a cell phone to connect to internet users. And I have a smartwatch with me. It monitors my health. So that is also an IoT application. For me, I have pretty much automated my entire house. So that is also kind of a like huge application of IoT in a real life scenario. Now, there are many other scenarios in which is used in real life. I think computer vision, drones is a very important concept. So there are many things in which you can do it in real life. I'll give a very quick example. Uh, in my house, I have automated watering of plants. I have automated my lights. I have automated the locking and locking of door, all by using IoT. And I use a smartwatch, which again is based on IoT. I have a cell phone, which is the most extreme example of IoT. I have a car that is connected to the internet, and that keeps on sending me data. That is also a real life example of IoT. At this point, I'm gonna take in some questions from the YouTube channel by EDUREKA. So, what is your take on all the data in terms of IoT security being saved or used in this whole IoT concept? Well, with all those things that are going on in terms of data privacy and data issues, so yeah, like this is a very important, this is a huge research area uh, in terms of IoT. So when you're talking in terms of security, or the data, most of the times is data metadata, and this does not have to do anything with the user. Like when I design IoT systems, I don't take care of the user data. I just take care of the metadata that's being generated. and I make sure that there's like a security layer inbuilt, which does not deal with the user data part of it. Now, my take at a very personal level will be, unless and until these IoT stuffs are not used at a personal level, or like this does not have to do anything with a personal life altogether, then we really don't have to worry about it, to be very honest. I mean, what will people do by knowing when I'm switching on and switching off my light, or at what temperature I am keeping my AC? I mean, this data can be used a lot for analytics, but to like just this is my personal choice. Like, what will people do if they know me, if they even know when I'm switching on and switching off my light? And this data is just being used at a very high level in terms of doing intelligent decisions, which is rated to make your lives easier. But certainly, user data is not captured unless and until it is related to some personal area of use. But yeah, the data security part is a very important research concept of IoT. And I have seen areas in which uh, personal devices have a huge security breach. So that is why you got to be very careful. Is IoT related to blockchain anyway, and what are different career paths in IoT? Well, yes, definitely. Blockchain is a key security component when it comes to designing IoT systems. I mean, recently this trend has been going on in which you can design IoT system using blockchain, and yes, it's a very key component. And if you talk about the career paths, it's there in the future slide. I will explain it to you. How do you develop IoT projects in the cloud computing, and how it will help to prevent cyber frauds? Okay, so when you talk about cloud computing, the entire networking, the entire IoT, the Internet of part, the things is just one part of it, but the internet, all the networking layer, all this sits in the cloud. So when you're dealing with IoT, you're considering rule engines, you're considering devices which are sending data, you're considering processing of this data. All these things are part of, you can say, the cloud computing layer. And when you're designing IoT systems, if an IoT engineer, you naturally got to be a cloud engineer as well. But you need to understand how this data interact with each other, how these service buses interact with each other, how this data can be forwarded to several of these cloud computing services. Like, I specialize in Azure part of it, and I think EDUREKA have a lot of courses when it comes to Azure and IoT. So definitely cloud components are very important factor when it comes to IoT. I remember like there was one question. Yeah, can we implement service management from event management and continual service improvement? If you could explain this question, I thought this question was related to like handling lots of data, but now that I read it, I think Balakrishna, if you could just elaborate this question, to be great help. Then I'll take this question at the end of the session. And how do you develop IoT projects? I already tackled this question. Okay, now if I go back to the Q&A, there are lots of questions, probably more than 4 to 5. I think I'm gonna take all these questions at a later point of time after my event is done. So I have a dedicated like half an hour at the end of the session for just answering questions and answers. So Balakrishna, I will tackle your question at the, just drop the mail. I mean, drop your message in the chat, and I will tackle after we are done with this, with the remaining half of the session. Cool. So at this point, I'm gonna head back towards the main slide, and then again, I'll come back to you to answer this question. It is actually exciting to see so many questions coming up, and it is good that you guys are listening to it, and thank you for that. Keep throwing questions. I will answer whatever questions are possible at this point of time. Even if I'm not able to answer one or two, or if I'm not able to answer, I will address all those questions. Just drop me a mail. I will address all those questions at a later point of time as well. Cool. So from this point, resuming back to our slide deck, from this point, that is the automated guest visiting system and all the aspects of IoT, all the aspects of smart buildings. From this point, it will be a bit more technical front, and I will also try to cover the computer vision part of it and how it affects our lives. Okay, so let's consider some scenarios. The first scenario being automated guest visiting system. So let's say you're staying in a complex, and in this complex there are thousands of tenant owners. You have a, like in a place like Bangalore. I used to stay in Bangalore quite a few days. I mean, a few years back, in 2016 to 2017, and I remember the complex that I used to stay had many buildings, many tenants, many owners, many PGs, many rented apartments, and like there used to be a hard time in coordinating like who is entering, whether it's a Swiggy guy, whether it's a Food Panda guy, whether it's Amazon delivery guy. It used to get a bit difficult, or whether it's a actual guest of the uh, the owner of the particular property. So it used to get very difficult. And lately, what I have seen when I used to visit Bangalore after I left the place, then I've seen like people using different apps in which they used to enter the card number and also the name, collect it from the guest and send it to the particular owner. And then the owner is to approve or reject based on whatever information he or she receives is in the mobile app. Now, this kind of system I have seen actually being implemented in some of the complexes. Now, this is also a smart system. I think this app is called MyGate or something. I don't remember exactly, but there's something related to this. So my point is that this is pretty much a good system implemented. You don't need to call in the intercom and get it verified. At most you can do is that you can use an app to do it. However, we can step one further step above this. We can automate this process. How? Now, there are multiple ways to do it. Suppose, let's say you are the owner of a particular house or property, or I mean, you're living. You take your car for a spin, or you take your two-wheeler for a spin. You come back, and the CCTV camera scans your number plate or registration plate. Since this registration plate is already associated with your name, and since you're the owner of the house, the gate will automatically open for you. This is one scenario. So you don't need to show your face to the guard, and if the guard recognizes you, and in some cases if that's a new guard, then it's a whole new level of problem. So if the guard recognizes you, then he or she will open the door and so on. But if it's a guest, what you can do is like extract number from the registration plate. Now this is where the AI concept comes into picture. Click a snapshot automatically of the face who is actually driving the vehicle. The driver might need to tell the name to the person or to the guard, like who is actually coming, and send the notification to the owner. Now the owner will just accept or reject based on whatever information the system has forwarded to the owner. Now this will include registration number of the vehicle, the guest details, which might include name for the purpose of visit to the owner, and based on that, the owner will either accept or will reject. This is a very like a very automated high-tech scenario of an automated guest visiting system. And you might even inform the owner like my vehicle number is this, or so automatically your door will open. That kind of system can also be implemented. And the entire point of the second half of the session today will be this part, the AI on edge part of it, because this is where things gets a lot interesting and it gets a lot challenging as well. So this is something that we will be exploring today. Before that, let's just have a look at building safety. Yeah, cool. Yeah, so building safety and predictive maintenance. This is something that I have discussed kind of in the previous slides, as in how you can increase the safety and maintain your building autonomously using sensors. So buildings are always prone to stress and strain. We all know that. And if you're living in a region like where I live, where it's a seismic zone 5 area, and we keep on having earthquakes every now and then. So obviously monitoring the health of a building is very important. Rainfall and other climatic conditions affect a building in many ways. That is also true. As I said earlier, I had to install a truss to save my ceiling, to save my roof. I have to install a truss. Then the quality check of the following system should also be ensured, which includes a water subsystem and electrical subsystem. I pretty much discussed this as well. The electrical subsystem, how I at a personal level was able to reduce electrical consumption of my house, and the water subsystem is something in which you can automate your pumping, like your water pumps you can automate, or you can automate your or you can check the quality of water. Now, what parameters you need to check, we'll discuss very soon. But there are many scenarios in which you can monitor or perform a quality check of the things, and all these things comes under the predictive maintenance. Now, why predictive maintenance? Because we collect a lot of data in terms of quality check, whether it's electrical subsystem, water subsystem, or the stress and strain levels of a building. And all this data combined can help us give a predictive analysis using machine learning or statistical analysis, like when the building should be maintained or when it actually needs a repair job. So these kind of things are also very important when it comes to concept of futuristic buildings using IoT. This is something just I could bring up from the previous slide somewhere back, where those three components are mentioned. Now, this is a kind of a smart house framework, and this to some extent will clear the question of Arpan, who has mentioned like how this connectivity can be done. So if I just go through each of the components, we have the electrical sensors, which are the current sensor, the voltage sensors, basically the consider smart meters. All the sensors will capture the electrical subsystems data. Now, this electrical system will include the power consumption, the time period for which a particular instrument was running, the amount of power that is being drawn from your mains, electrical mains, for that particular load. Uh, your stand fan might be like quite old and requiring a lot of electricity to run than a new modern stand fan. So there are many factors that you can monitor using electrical sensors. Then you have the water monitoring sensors, which will improve the quality of water, um, which includes the pH level, which will determine the alkalinity or the acidity level of water. So it has to be on the neutral area, but some areas I've seen is either a bit alkaline in nature, and a worst case scenario, it might be even acidic. So you have to be very careful about that. The the turbidity, the conductivity, and other parameters which are required for water monitoring. So that is also very important. And finally, we have the AI on edge part, which includes the computer vision part, based on smart recognition or smart object recognition. Now, all these three subsystems are connected to a local IoT gateway. So all these three sends data to a local IoT gateway using some kind of protocols. It can be LoRa, it can be Zigbee, it can be BLE, it can be Wi-Fi as well, it can be anything. So once the local IoT gateway receives this data, it is connected to the cloud layer of it. So by this cloud layer, I'm referring to either Azure Cloud or your hosted IaaS service or anything as such. And the user interacts with the cloud. So there is no direct connectivity from the user side to the sensors, because that will provide a breach in security, which you don't want. So all the data exchange has to happen through the cloud, and cloud takes care of all the security part of it. Now here we can like I can suggest you some IoT platforms as in AWS IoT Core or Azure IoT Hub, or there are like ThingSpeak, ThingWorks. All these IoT platforms are there that are quite widely used in this all scenarios. They handle the security part of it, they handle device management part of it, and that's how the considered smart house framework is attainable. And just to add on, like this might be a hybrid system as well, in which you have the sensors connected to local IoT gateway to the cloud, and then you have another group of sensors which are directly connected to the cloud. However, when you're designing this IoT system, you need to make sure that the user should not have direct access to the sensors. Then it's a breach of security. Whatever happens, it has to happen through the cloud layer of it. And if it is hosted locally, then that local connectivity has to be there. But that also has to be through a managed server. So um, my main point is that the security part of it has to be taken care when designing the IoT system. And that's what I have been doing at my company as well. Like whatever we do, we route through a single combination of services like routing and authentication service. And all these are happening in the cloud level. So we have full control of the device, as in uh, like, I mean, in terms of data, in terms of security, we have the full control over it. And that is very important when you're designing an IoT system. So at a very high level, this diagram pretty much summarizes the entire smart house concept using what kind of framework we use. And I will just give you some names, which includes the MQTT protocol, the AMQP protocol, and the many more protocols that can be used. Even HTTP REST API calls can be used for transfer of the data. Now here I'm not going to discuss about this protocol because that will take another day altogether if I keep on start discussing on all those terms. So yeah, it's more specifically like how you send the data. So how does AI plays a role out here in the entire concept of smart buildings, in the entire concept of IoT? How does AI comes into the room? Now there's a very important concept. Like right now, people don't do IoT, people do IIoT. The initially level, I thought like IIoT means Industrial Internet of Things, because I'm a kind of a guy who comes from electrical background. So when it comes to AI, the IIoT is actually referred to as intelligence Internet of Things, intelligent Internet of Things. So what I mean to say is that it's not only like tackling the data. It's not about like getting the data, uh, but also it is about like how we are analyzing the data and doing some modeling on top of it. Like how you are analyzing the data to do some data science stuff, to analyze, to predict the outcome, the predictive analysis, all those things come to the picture. Now, how this AI plays a role in the concept of smart buildings or futuristic building is to computer vision, because object recognition is an entire concept of machine learning and artificial intelligence and deep learning using neural networks. So that's a completely different section of computer vision. And Intel has a very cool toolkit, the open source toolkit known as the Intel's Open distribution, which we can use to do the computer vision part of it. Then you have data analytics, in which the amount of data that you collect from the sensors, um, from the like water sensors, from the electrical subsystem sensors, all this data that you collect um, can be a part of the data analytics. So you can have a machine learning model analyzing your data every now and then and take an intelligent decision. And then we come to the last point of predictive maintenance. Like we take the data, we take all this data, we try to analyze it using machine learning modeling, and finally we get the like we recommend the user that this kind of predictive maintenance should be done on this particular subsystem to improve the quality of the building altogether. So this is where AI plays a extremely major role out in the field of IoT, and in the use case specifically related to smart buildings. And here where we actually enter into the whole new world of AI, but very specific to IoT. So when it comes to computer vision, cloud level processing isn't at all a good idea. Now, if I go back to this framework, you have electrical subsystems, you have water monitoring system. Now, this all will generate data, probably not always, probably once or twice a day. And this data usually in the form of textual data. So it is not very huge in size. Now, if we are dealing with AI on edge, or rather computer vision data, just remove the concept of AI on edge as of now. If we're dealing with computer vision data, these are all video files or camera images. Now, to transfer the data to the internet live will consume a hell lot of bandwidth, which you don't have. Especially like if you consider Indian system, we don't have that luxury of using internet every now and then. uh, I mean, just dedicate internet service only for transferring the images and videos, that we don't have the luxury of doing it. And that also analyzing it, it consume a lot more power, lot more bandwidth, and that's not desirable. So here the concept of AI on edge comes in the picture. We do core level of processing at the edge level. So by edge, I'm referring to the device level. So we do the processing, we extract the images, we extract the objects, we do everything at a edge level or the device level. Like your CCTV camera is connected to an Intel edge device, and that will take care of the processing. Now, what we do is that we take care of the process data, we convert it to a metadata, into textual representation, and that data we send it to the cloud. So try to understand the concept, like we are not doing the processing at cloud. We are doing the processing, the main image processing or the main video processing at the edge level. Once that processing is done, we generate the metadata or the textual data that we transfer to the cloud. So it saves a lot of bandwidth. At the same time, you can upgrade your code base at the edge using the deployment tools that are available, using OTA or using whatever you want. But the main processing of the image, the video happens at the edge. So that's where the name AI on edge. And that's where Intel had done a lot of progress in terms of using the Opencv toolkit, which we'll discuss. Now, why you want to use the AI on edge? It saves a lot of data bandwidth first and makes the process a lot less complicated. Because if you want to handle the real-time streaming of data over the cloud, you have to design quite a complicated system, which may take a bit, which might be a bit challenging at a, like what I think personally. And if you do it at the edge level and just transfer the metadata, that makes things a lot simpler and easy to manage. And that's the whole point. And nowadays, using a single edge device, or you can using a single AI on edge unit, you can parallelly process like 30-40 frames per second data. So that is also kind of very useful in our scenario. Um, it's not that for each CCTV cameras you need to have one dedicated system. It's not like that. For a combination of, let's say, 10 CCTV cameras, we can connect it to one edge system, and that will send a metadata to the cloud, and that's how this process will happen. Even that I mentioned earlier, like registration, place recognition, object recognition, facial recognition, we'll just generate the metadata and send it to the cloud for the cloud to take the intelligent decision. However, all the core level processing we are doing at the edge level. So computer vision frameworks that are available for edge processing. If you have just noticed that we are um, shifting from the concept of IoT to the concept of intelligence, and here where things gets a bit more interesting. So under computer vision framework for edge processing, we have Opencv. I think pretty much everybody knows about Opencv. And then finally, we have the Intel's distribution of Opencv toolkit. And this particular toolkit is where all the magic happens. And I have used this toolkit for many years as of now. It's not like I usually don't work with stuff which does the work for me, but it actually did help me a lot. And that's why I'm talking about this particular distribution. It's open source. You can just download it and you can use it on your own system. So what this does is that excuse me. So what this does is that you have, let's say, if you have a CCTV camera. Now, when you take the video from a CCTV camera, what is a video essentially? It's it's just a collection of frames, a collection of static images. When we say 60 frames per second, so we capture 60 frames per second, and that gets converted to a video. And at the same time, we keep on capturing the audio. So that's how it happens. So we have Opencv, which will does a like very base level processing for us, and then the Intel distribution of Opencv toolkit, which internally uses Opencv obviously, and uses a lot of machine learning models and deep learning models and neural nets, which will uh, basically like consume those images, process those images, do the inferencing, and get us a result. So when we are dealing with AI on edge, we need to process at the edge level. We need to process at like get the information out from those images or videos at the edge level, and that's where these two things comes a lot useful. Now, what exactly is OpenVINO toolkit? Now, if I talk in terms of machine learning or like computer image like color image processing or video processing, then there are usually like a couple of components. We have we have something known as like a model, which is essentially like a black box where you provide an input and you get an output. Then you have the input image and the output image. So what happens is this model is that initially you need to collect a lot of images and then create that model, something which we call the process of training a data set. So we get a data set, we train the data set, and we create a model. And then once this training has been completed, we take an input image, pass to the model, and get the output. Now, OpenVINO is not responsible for the training part. What it is responsible is for the inferencing part. So at one side you have training, and on the other side you have inferencing. And if you combine these two together, you have this entire machine learning framework. So what using OpenVINO, what we can do is that we already have a trained model. We convert into something which is compatible with the OpenVINO toolkit. So let's say we have a trained model, then we run something known as the model optimizer. I won't go much in technical because that requires a different level of discussion altogether. So once we have the model optimizer, we generate a couple of compatible files and use an inference engine, and the user application interacts with the inference engine to get the inferencing done by this particular framework. So what OpenVINO will do for you is create that um, intermediate layer, create that the intermediate representation or IR, which we call it as here. So OpenVINO will create that for you, and then you have the CCTV cameras. Your piece of IR is running in your local system. So all these frames keeps on coming to the inference layer or the IR layer, and it like the input comes in the form of images or videos. We get the output, and that's the OpenVINO comes in a picture. Now, why OpenVINO and why not the other data available? Because we write a single piece of code and it can be executed in different edge systems. As in like we can execute it on a GPU, we can execute it on a CPU, we can execute on an FPGA, we can execute on multiple areas. That is kind of important because if like this is something, I'll just narrate you a story, a small story. This is what happened with me. So at the very early stages, back in 2017, when I actually started to learn how to drive, I took out my car on a heavy foggy night, which was a first mistake. I took out my car and I was just going to fill up my petrol because the next day I was going to visit someplace. And it has been like 2 months I learned driving. So I was driving my vehicle in a foggy night, and for some reason or the other, my inside of the car windshield fogged up, and I was not able to see much. So by the time I knew how to clear that inside foggy condition, like when it started clearing from the down, I saw a divider in front of me. My car hit the divider and it got overturned. Fortunately, nothing happened, just a minor scratches came, but the car was completely like, I mean, not destroyed. We repaired that car, but it was not in a drivable condition. And that was a bad enough accident. And when I recovered from that accident, when I got my car back, I started to wonder what went wrong. I mean, uh, this shouldn't have happened. So what went wrong? So so then I realized like I need to implement some kind of system in my car which will help me to detect the telemetry data of the vehicle, as in what speed I was driving, what was my gear, what was my engine RPM, and at the same time um, scan the my environment, as in what condition I'm driving, whether it's a rainy condition, whether it's a foggy condition, whether it's a sunny road, whether it's a hilly terrain. I need to analyze that data. And then, and actually this incident like kind of forced me towards exploring the AI part of IoT. Before that, I was also kind of comparing like, this is IoT, what will AI come into the picture? And then I realized how AI is important in the like field of IoT. So then I design a system in which I was capturing the data from my car in something known as an OBD port. And I like fitted a dash cam in my car, and I fitted a small NUC, like it's a small computer. It's manufactured by Intel. Thanks to Intel, I was able to get that device in time. I connected all the components. I developed, like I trained a model using Opencv Toolkit, and I was able to detect multiple parameters, as in the frequency of the vehicles, like number of vehicles on the road at that time, whether it's a foggy condition, whether it's a sunny day, whether I have clear visibility, all the parameters I was monitoring. And then I realized like how much important it is, because the very next month my driver was driving the vehicle. I was not in my car, I was in my home, and he was kind of going to meet with an accident. He actually dozed off because he's driving to a straight section of the road, and he was trying to like he was kind of dozing off. And then when he returned when he returned back, I was able to go through all the parameters and then determine like what went wrong. And I just wish I had the system in the first place when I met up with an accident. Then probably that could have been avoided. So, and nowadays pretty much every car comes with this kind of systems inbuilt to it. I had a Wagoner which did not have any kind of safety features, and by the time I sold my Wagoner, it was a high-tech car with many features inbuilt into it. So that's what forced me to enter into this world. And not only in the concept of vehicle monitoring, but also in the concept of other stuffs, like as in like in the case of smart buildings, when you are entering a building, when your car registration number plate is being scanned, all this comes into the concept of AI on edge processing, or your face is being detected and then sent it for recognition, handling the metadata part of it. All this comes into the concept of AI on edge, and why it should be used. You should not depend on the cloud for processing. You should kind of, when it comes to computer vision processing, you should depend on the edge part of it. And that's the interesting part. So moving on, I will just probably try to, you can also go through it, the dev cloud. So here's the URL. It's devcloud.intel.com/edge. I think by the end of the session you should be getting a license to use it. So what it does is that it will provide you with an environment to use the Opencv as a whole. And this will be like, you don't have to have physical devices to see how your model is performing. You can test it in their like in the dev cloud environment, and you can see how your model is performing. And it has a lot of features, and how you can use the model, what is the efficiency of the model, uh, like what are the cases of false detection, or what are the cases of uh, true detections. All these things can be monitored. So I don't know whether this will be visible or not. I tried to bring it up. Uh, See if I could bring it up. I'm gonna stop sharing and again start the sharing so that it will be clear. Yeah, I think you should have, yeah, you should have the Intel Dev Cloud window open in front of you. I think so. Cool. Just can anyone know? Let me know if this particular window is open. Okay, perfect. Thanks. So this is a page for the homepage for the Intel Developer for Edge, where like you can go to the documentation, the OpenVINO overview, the DevCloud overview, and the tutorials. There are a lot many tutorials. Like, you can just sit here and keep on learning. is not that much of a big deal. In the lot many today, you can even have the sample applications to try out. I mean, what happens is that why I started using this dev clouds. Again, there's a story behind it. I don't have the I was not having the funds to go for like high tech devices to test whether my model will work or not. So here, what we can do is that we can have multiple edge devices assigned to an account, and since you guys are getting this for free, there can be nothing be better. So like you have FPG, you have GPU, you have CPU, you have the Xeon Phi CPUs, you have all these things connected to your account at a physical level at the cloud. And whenever you deploy some kind of a model, you will be able to you will be able to see how your model performs in those hardwares. So when you are actually designing your smart building ecosystem at your house or at your locality, or at your client's end, then you will be in a position to recommend the client or to recommend the owner to buy this particular edge device because you already know how your model is performing. So that's a beneficial part of it. Even before playing with the hardware, you know how your model is going to perform in the particular piece of hardware. So that's why this dev cloud for edge I have been using for a long period of time, and couple of my projects are already based on dev cloud, one being VAMS, or vehicle advanced monitoring system, which I mentioned to you earlier regarding my accident. So that was the inspiration of the project. So you can search over YouTube the VAMS project and you will get some kind of information regarding it. So at this point I'm gonna head back again to my PPT deck, and I will stop the screen share and again start it. So share screen and share. Cool. So here was a question that many people asked today, and that is, how do we get started with IoT? Where is a chat window? This is, yeah. So many people ask this question: how do we start with IoT? And that is actually very interesting because many people ask me this question when I do sessions in like offline mode as well. So yeah, it's a multidisciplinary field. It involves lots of stuff. And I think some people asked me like this thing. There was a question in which like, what is the software part of IoT? And I mentioned that 10% is hardware and 90% is software. So here is the big deal. You have like, this is the parts you can explore. Electronics design. You see this, that's just only one point. Nowhere in this entire list you are involving hardware. Electronics design, wireless communication engineering. This is kind of hardware and software combined. Firmware development, software development, and cloud computing. Now you can get a very good idea like why IoT is an interdisciplinary field. Now in the software development, your machine learning will come into the picture, your application development will come into the picture, and cloud computing, it's all about like being the cloud architect, and how you can interface with multiple systems all together and explore it. So if you want to begin with IoT, just try to get focused on what area you want to explore, uh, whether it's a hardware part of it, or whether it's the software part of it, whether it's a cloud computing part of it. Whatever you want to explore, just make sure you know that, and then you can move forward with that particular field. So how do I get started? So start with a basic end-to-end project. Now this can be any, starting from home automation to machine learning to any kind, to automated irrigation system. Start with any basic end-to-end project. There are tons of tutorials even at EDUREKA and even in YouTube, uh, like how you can use it. I mean, how you can do a very basic level IoT project. You can might even do a simple home automation, like you switch on and off a light using a mobile application that will do, and do it from scratch. Don't use any framework, don't use any tools that are available. Obviously use the protocols, but try to keep it as open source as possible, and experiment with a lot of new devices senses. Now this is something which you can which like the hardware enthusiastic can use, like estimate a lot of devices. There are tons of devices available in the market, starting from Arduino. I think I saw a question here somewhere regarding Arduino. I don't remember what was it, but somewhere I saw this being mentioned. I will come back to that. I am not able to get that question. Anyway, so basically what I mean to say is like explore with new devices. You have Arduino, you have Raspberry Pi, we have STM32 series microcontrollers, you have ARM Cortex microprocessors, controllers, all like the many devices, there are lakhs of devices available in the market that we can use today for building IoT systems. Then choose your area of expertise, like what you want to do. You want to go into firmware development, you want to go into PCB development, you want to stick with cloud computing, you want to stick with system architect or system engineer, which I am at this point of time. You want to design the IoT system, you want to be a security expert of IoT, stick to your field. And finally, just a bonus added pointer, do courses from EDUREKA into this particular landing page, which is edureka.co/IoT hyphen certification hyphen training. So do this, probably you can do these courses, and then you'll get a very, if you follow these things from start to beginning, like start with a basic end-to-end project, much of the things will be cleared out. And if you do an end-to-end implementation project from scratch, then you will come across a lot of problems. And trust me, if you come across a lot of problems, then you'll understand how the systems actually work. When I started with IoT, I ended up frying up more than tens of devices. So at this point of time, I even started keeping a file extinguisher in my room. And we keep on estimating a lot of new devices and sensors. We choose what you want to explore, what is your area of expertise, and then explore that, and finally do lots of courses. And yeah, that's it. So probably this is the end of my event. And at this point, I am gonna open up the channel for question and answers, such that you guys can also keep asking me questions and see uh, what can be done. So I will take up all the questions right now. So I'm gonna begin with, here is the thing. So can you suggest few projects in IoT and Arduino as a beginner? Well, Janvi, to be honest, you can start with basic like automation projects. Like you can take an Arduino, you can take a light bulb, you can take a relay, connect it to the electrical. Be careful when you're handling electrical system. Don't end up getting a shock. So you can connect the systems, you can switch on and off an electric bulb using Arduino. You can develop a mobile app using either using raw coding or using MIT App Inventor uh, to interact with an Arduino using Bluetooth or using Wi-Fi, and then get started with it. Uh, it's very easy to get on started with IoT. Initially may fail, but that will be helpful in understanding how the systems actually work. Is so then the next question is only Python programming enough if someone wants to build a career in IoT software profile? To some extent, it is yes as well as a no. Why so? Because if in software profile you're speaking in terms of IoT, then not only Python, but using Python you can do it obviously, but there are other things also you need to look into, like when you're talking about cloud computation, like what all programming languages it's supposed. If for some instance the Python, the IoT platform does not support Python, then obviously need to shift to others, something like a Node.js or something like a Node-RED or something of that sort. However, according to me, I'm a huge Python fan. I also develop most of my components in Python as well. But sometimes, in some cases, Python does not work out. When we shift to some other server-side language, probably Node.js or that's mostly it. So, if you want to build your career in the software profile of IoT, then Python is a good choice, but definitely not the only choice. Is 5G help to use more IoT devices in India? Well, this is a very interesting question, and I will take this up. 5G is very, when it comes to IoT, 5G is going to be the future. Why so? Not the technical 5G that we are going to use in cell phones. Obviously, 5G can be used for like a couple of things. The first one is sending video. So if you have if let's say if you are not doing AI on edge level, if you are actually sending the video in the cloud, then you need a huge network bandwidth, which only 5G can support. Now, using the 5G technology as a base, NB IoT and LTM is launched. Now, these two, LTM and NB IoT, are not 5G based services, but they're dependent on 5G, specifically designed for IoT. So yes, 5G is going to help us develop a lot of IoT devices and connecting a lot of devices in specific to the Indian subcontinent. And please discuss how much computer programming knowledge is required for IoT expert. Well, it requires a fair enough expertise in terms of programming, because you need to deal with a low battery power, low bandwidth, huge number of redundant systems to kick into action if something goes wrong. So you need to have a very strong programming knowledge in terms of how the system works, and also in terms of how you can integrate multi components under a single platform. Internet of Things easily means current all your things right, and that is correct, Arpan. How to apply IoT concept in rural areas for agriculture purpose? Well, this is something that I'm also working on currently as a part of my research project, in which I mean, just consider agricultural field. There are tons of sensors to it. There are tons of there are like multiple areas in which sensors can be used, and in all those scenarios, you embed these sensors across multiple, I mean, huge hectares of land. All the sensors are connected to either LoRa or Zigbee to a gateway, and you are getting the data. Now, it will definitely ease out the job of the farmers. I mean, they will be much more in a relaxed position because they will be able to use technology, not only in monitoring the sensor data from the soil and from the plants, but also in spraying fertilizers using drones is also a very important concept that can be used in rural areas for agricultural purpose. And the concept of drones specific to the terms of IoT and agriculture is becoming quite prominent now in India. And since DGC has ruled out new rules and regulations for drone operations in India, and it's NPNT compliant rules and laws of drones, so definitely it has a huge potential in the rural area of IoT in specific to agriculture. Now, what is the difference between robotics and IoT, or can we say that robotics is a big form of technology of IoT? Well, to be honest, I would say that IoT has a subsystem of robotics. It's not that robotics is a subsystem of IoT, or it's kind of intermingled in some way or the other, because robotics involves sensors, actuators, machine learning, applications, and many things. While IoT also involves the same. So you can see the robotics subsystem of IoT or IoT subsystem robotics, whatever you call it. But at the end of the day, it follows pretty much the same architectural model. But in robotics, we consider a lot on the control system, like how the actuation should happen, how the actuators should react as in industrial robots. So that's where the research comes in a picture. However, more on the control side of it, like how you're controlling the robot, how you're controlling over the internet, that's where IoT comes in the picture. Can an EC student can work in IoT? Well, I am an EC student. I am working in the field of IoT as an IoT lead. So definitely yes. Cheapest hardware for IoT. What about ESP32 module? Yes. So here is a trick. In many industrial projects, as of now, ESP32 and ESP826612 is still being used, and is one of the most stable Wi-Fi boards that I have ever come across. So definitely, it's a very good choice. Cheapest form of IoT hardware as of now is the ESP826612E or 12F series, which is very stable and highly used in industry. Even the smart bus uses ESP8266 and ESP32. So definitely yes. TensorFlow Lite works on which IoT hardware? Well, when you're dealing with TensorFlow and or TensorFlow Lite, if you remember my slide on AI on Edge, that one uses like the AI on Edge concept is totally based on Opencv, and Opencv internally uses either TensorFlow or Keras. So definitely, if you're dealing with hardware like a Raspberry Pi or for either like a Raspberry Pi or some form of Linux-based boards, then TensorFlow can be used for those devices. And I have used TensorFlow on a Raspberry Pi, and it works pretty much well, although not very up to the mark, but it does a job. For the IoT user and designer, what should be the minimum qualification like as a bachelor's in? I am a BTech in EC, 2016 pass out. So, and I'm working as an IoT, and there are tons of guys who are working in the same qualification. So this should be the minimum qualification. However, I have seen like now with the latest trend being kids learning programming, I kind of don't support that idea, but yeah, I mean, if you know programming and if you know uh, how the system works, if you have some idea about the base of the system, the basic level, how the circuits work, how this programming works, then that should be the minimum start point. And as of now, I think companies started, I mean, companies don't even look for qualifications. What they look is what is skill set you have. So that way it works. Now, I think Q&A from the Q&A chat box is done. Now I'm going to take up the question from the chat box. So, okay. So thanks, whoever has appreciated. Uh, okay, Anuj Gupta, how to make a career in IoT? I think I've already raised this. I mean, I have already tackled this question in the slides. Like how do you start with IoT? And how I started is that I worked for a software company. I was not liking the job. I left it, and then I joined this company as an IoT developer. And slowly, I became the IoT lead. And now we are developing products on IoT. So it's all about what is the product you're working on, what is the company that you're working with, and all these things takes in action. But if you want to build a career in IoT, stick to a particular point. Like I stuck to the concept of system engineering as in how we can integrate multiple components. So you need to focus on a particular area of IoT that I've discussed earlier. And that way you can step up the ladder, the corporate ladder, and be in a respectable position. For the IoT, what is the future of AI and IoT? Well, the future is all about AI and IoT, to be honest. Starting from smart systems to smart buildings to smart cities, everything which is a smart keyword in front of it involves AI and IoT. And nowadays, everything is shifting towards AI and IoT. Think about 5 years back. We don't know what is home automation. We didn't know what are the smart speakers like Alice and Echo. Now, fast over 5 to 6 years, and we pretty much know everything about. I mean, pretty much everyone is shifting to IoT, to smart bulbs, to smart fans, to smart power systems, to all those things. So there's a huge transition that is happening, and there's a huge scope in terms of AI and IoT in the future. For IoT user and design, what's your minimum engineering? I think I already answered that question. How can we test basic IoT hardware and software? So, okay. So when it comes to testing of basic IoT hardware and software, what I follow is like what can go wrong and to test what will go wrong. So if you, if you do all the negative test cases and the positive test cases, will automatically align to each other. So the greatest problem that we face in IoT is frying of devices. And I personally have fried up more than tens of devices. And I'm okay with it because if you do not experiment, then you won't be able to learn. So in terms of hardware, there is a lot of scope for testing IoT devices in terms of security testing and many things. But when it comes to software, we can follow standard protocols that the software testers used. What will be the future of AI and IoT? I already covered that. AI model trained on high-end machine while trained model implement a low-cost IoT. Is it possible? Yes, that's what we discussed. We train the model on a high-end machine, then we build the model file, and then we perform inference on a low-end machine using either any AI on edge framework, whether it's an Opencv toolkit or Opencv. We use a already trained model and run it on a low-end machine to do the processing on it. RP is involved in IoT, the robotic process automation. RP, I think, is typically more of a software area, but if you consider robot process automation in terms of industrial process control or industrial assembly line, then obviously IoT plays a huge role in it. Chatbot is IoT or not? If you integrate a chatbot with physical devices, then definitely it's IoT. And I have done that using Microsoft Bot Framework. in which I was able to control my lights and fans using sentences, like switch on the light for room 2, and for room 2 the light will be switched on. So in that way you can consider it an IoT. If you want to work on IoT and make it as a business, for that, from where to start and what language we must know. So by language, if you're referring to programming language, and obviously all the high level languages and possibly low level, this is something I skipped out from my slides. But if you're dealing with hardware and firmware programming, then C or C++ is very essential. I mean, people use Python nowadays, but yeah, C++ is still the best when it comes to hardware programming. And when it comes to the software part of it, then Python, Node.js, JavaScript, and Java, whatever you want, you can use like the standard programming languages. As such, at this point of time, I honestly don't care about the programming language anymore, because it's all about which programming language suits the best use case. So for a specific use case, Python might be the best choice. Then I'll go for Python. For any use case, Node.js might be the only choice. Then I'll go for Node.js. So it all depends upon your use case. I think I have answered. Okay. What all knowledge a person should have to become IoT, right? I have already covered that. Give some examples of software-based IoT projects. I think pretty much all the projects that on IoT have 90% software to it. So yeah, I mean, home automation, the cloud computing part of it, the mobile application part of it, those are software projects of IoT. So then the machine learning part of it, like how the predictive maintenance is, and all the software projects of IoT. So yeah, that pretty much covers it. Any more question? I think pretty much same question is kind of which language is suitable for learning and working IoT. Again, hardware, C, C++, Python. For software, whatever suits the best. I personally choose Python and Node.js. Yep, that's it. If any more questions, please drop it, or I'm gonna drop my email address in the chat window. It's avirup.basu@live.com. Okay, there were two more questions. If you want to work on IoT and make it a business, as a business, from where to start and what language you use, I already tackled this question. Can we see a future where we need not install a sensor, instead we'll use nanotech for building buildings, and still IoT will do the job for automation? Well, extremely interesting point, Sudipto Pal, you brought up. And yes, the day is not far when you're using nanotech, but yes, it will be sensors based on nanotech. For now, I'm working, I cannot expose the details because NDA compliant, but what I can say is that we are working on sensors that can be embedded within a body to detect your vitals, not as a smartwatch, but as a nanosensor. We are working on that as an external research project. I'm involved with it. And the day is not far when we actually rely on nanotech to do the job of sensors for us. And nowadays, a lot of research is being poured into this, using graphene method, using nano stitching, carbon nanofibers method. Many things are happening at a huge research level in the education institutions when it comes to nanotechnology and how sensors can be developed as a nanotech. It's a very interesting question. I am fortunate enough that somebody asked this question. I was not expecting this question, so that's great. Well, thank you everyone for attending this session. It was indeed a pleasure for me to deliver this session, and I think it was a fruitful Sunday morning for you guys as well. So yeah, that's it. I think Sahiti, you can take up.
Yeah, thank you so much, Avirup. It was indeed a very good session. I think the way that you've shared your knowledge with all of us, it was fantastic, right? So hopefully, I hope that all of you have also enjoyed the session and have understood how to, use smart building using IoT, right? So that's all for today, guys. I hope we can stay tuned the next time. So until next time, if you have any queries regarding the session, please email us the queries on the email ID that has been shared, and we will be more than glad to respond to the queries. So that's all from our side. Thank you so much, and all
Thanks.
of you have a great day. Thank you, Avirup.